Good morning to all of you. Today we will do the problems on shear force bending moment diagram. The subject is mechanics of solid mass. Mechanics of solid. Right? This is question number 60. This is question number 60. Clear? Now the question is a beam AB simply supported and B carries UDL of 1500 Newton per meter over its entire beam and takes 3-point load 1000 Newton, 2000 Newton and 3000 Newton at CD S1 figure. Draw the shear force bending moment diagram for the beam. Clear? The question is a beam AB 6 meter long carries a UDL of 1500 Newton per meter over its entire beam and carries point loads of 1000 Newton, 2000 Newton and 3000 Newton at a point at CD at a points C, D and E S1 figure. Clear? Draw the SF and BM diagram. SF and BM diagram for the beam. Clear? This is question number 60. The question is the beam AB 6 meter long carries UDL of 1500 Newton per meter over its entire span and takes 3-point loads 1000 Newton, 2000 Newton and 3000 Newton at a distance of 1.5 meter, 3 meter and 4.5 meter from the left support. Draw the SBM diagram for the beam. Now, this is a simple supported beam. First find out the reactions at the support A and B. Let RA is equal to reaction at A, RB is equal to reaction at B. Clear? Now, first calculate the load. This is 1000 Newton, 2000 Newton, 3000 Newton. The UDL is 1500 Newton per meter for 6 meter long. So, the total load is 1500 into 6, reacting at 6 by 2 means 3 meter. This is UDL total load is equal to 1500 into 6 is equal to 9000 Newton at point D, because D is the middle of AB, 3 meter, 3 meter. So the total load is acting at point D. Clear? Now sigma y0, sigma y0. This is RA, this is RB. Clear? What is RA plus RB is equal to? RA plus RB is equal to 1000 plus 2000 plus 9000 plus 3000. This is equal to 3 plus 3, 6 plus 9000, 15,000 Newton. 1. Next, sigma A. Take moment of day. Sigma A is equal to 0. So it is RB into 6. RB into 6 is equal to 1000 1.5, 2000 into 3. RB into 6 is equal to 1000 into 1.5 plus 2000 into 3 plus 9000 into 3 plus 3000 into 4.5. Clear? So RB into 6 is equal to 1000 into 1.5 plus 2000 into 3 plus 9000 into 3 plus 3000 into 4.5. 3000 into 4.5. Clear? This is equal to RB into 6 is equal to, this is 1500 plus 6000 plus 9003, 27,000 plus 3000 4.5. 312, 12,000 plus 1500, 1350, 13500 Newton. Clear? ठीक, correct. Now this is equal to 13500 plus 1500, 15,000 plus 6, 21,000 plus 27, 48,000, 48,000 Newton. What is RB is equal to? RB is equal to 48 by 6, 8,000 Newton. So what is RB is equal to? 8,000 Newton. RA. What is RA? From equation 1. From equation 1, what is RA plus RB is equal to? RA plus RB is equal to 15,000 Newton. What is RA? 50,000 minus RB. 50,000. What is RB? 8,000. 7,000 Newton. R is equal to 7,000 Newton. What is RB is equal to 8,000 Newton. Right? Now make calculation for shear force. This RA, what is RA is equal to 7,000 Newton. 700 Newton. What is RB is equal to 8,000 Newton. Now make for shear force calculation. Now shear force at B just right. Shear force at B just right 0 because before B there is no load. So at B the load is 8,000 Newton. That is calculated for left of B. Shear force at B just left minus 8,000 Newton. E left, E right. Shear force at E just right minus 8,000 plus 1,500 into 1.5. 1,500 into 1.5 is equal to minus 8,000 plus 2250. Clear? 5750 Newton. This is shear force at E just right. At E the load is 3,000 Newton. At E shear force at E just left 5750 plus 3,000 minus 5750 minus 5750 plus 3,000 is equal to minus 1750 Newton. Clear? Minus 1750 Newton or just left minus 5750 plus 3,000 is equal to minus 1750 Newton. E left, then D right. Shear force at D just right minus 1750 plus 1500 into 1.5. 1500 into 1.5 is equal to minus 1750 for this. What is this? 2250. So 500 plus 500 Newton. This is for just right, then just left. Shear force at D just left 500 plus 2000, 500 plus 2000, 2500 Newton. Now at D left, D right, D left, E right, E left, B right, B left. Now come to C. C just right. Shear force at C just right. 2500 plus at C 1000, 3500 Newton. Clear? Now C left. Just right. 2500 plus this load 1500 into 1.5. This is equal to 2500 plus 2250, 4750, 4750 Newton. She just right. Then C left. Shear force at C just left 4700 plus 1000, 4750, not 00, is equal to 5750. Clear? B right, B left, E right, E left, D right, D left, C right, C left. At A. Shear force at A just right 5750 plus 1500 into 1.5, 7000 Newton. This is 2250 plus this. Now this should be minus 2750. Sorry, 2750. Clear? This is minus 2750 plus 2250 minus 51 minus 2750 plus 2250 is equal to minus 500 Newton. Clear? So minus 500 plus 2000 at D right. So 1500 Newton. D left. Then C right. C right 1500 plus 1500 into 1.5. So 1500 plus 2250. So 3750. Clear? She just left 3750 plus 1000, 4750. Right? A right 4750 plus 1500 into 1.5 is equal to 4750 plus 2250 is equal to 7000 Newton. A left, shear force at a just left, 7,000 minus 7,000, 0. Clear? So negative sign makes our problem to solve difficult. This should be negative. 500 Newton will be negative. Clear? Now the answer is correct. This is correct answer. Now draw the SF diagram. A, C, D, E, B. Take scale 1000 Newton. Scale 1 cm is equal to 1000 Newton. Right? Now we just write 0. We just write 0. B just left minus 8,000. Minus 8,000. Clear? E just write 5750 minus. Clear? E just left minus 2750. 2750. Clear? Then D just write minus 500. This is minus 500. Then B just left 1500 plus. Suppose this 1500 plus. Right? Next. C just write 3750 Newton. This is 3750 Newton. She just left 4750 Newton. This is 4750 Newton. A just left 7000 Newton. This is 7000 Newton. Then A just left 0. 0. Clear? Now join all the points. Starting from B right. Clear? This is 0, 8000, 5750, 2750, 500, 1500. Clear? 3750, 4750, 7000, 0. This is shear force diagram. These all values are negative. These all values are positive. The both baseline positive, below the baseline negative. Now Clear? This is positive, this is negative. The shear force changes sign from negative to positive at point B. So at this point, the bending moment is the maximum. Now we'll find out the bending moment at point A, B, C, D. Small negative sign makes our problem difficult. Clear? Now, bending moment calculation. A, C, D, E, B. BM calculation. At B 0. Bend moment at B 0. In case of a simple solid beam, the bending moment at the two supports are 0. Now, at T, BM at T, just write this is point E. So, RB into this was 1500 into 1.5 into 1.582. This is 1.582. Clear? So, RB into this positive, this is negative. So, at E is equal to at T, not just right. BM at T, RB into 1.5 minus 1500 into 1.5 into 1.582. What is RB? 8000 into 1.5 minus this is 750. 750 into 1.5 into 1.5. Clear? It E is equal, bending moment at E is equal to 10313 Newton meter. 10313 Newton meter. T. Then count point D. At D. Bending moment at D. At D. RB into 3 minus, this is 3000 into 1.5 minus, this is 1.1500 into 3. This is 1.500 into 3 into 3 by 2. Clear? RB into 3 minus 3000 into 1.5 minus 1500 3 by 2. Clear? This is RB into 3 minus, this is 3000. Clear? RB into 3 minus 3000 into 1.5 minus 1500 into 3 into 3 by 2. Clear? This is value D. The answer may be at D. The answer is 12750. 12750 Newton meter. Let's see. BM at C. Let's see. Come from left. All moments are taken from right. I will calculate for C from left onwards. Clear? So RA into 1.5. This is 1.5 minus 1500 into 1.5 into minus 1500 into 1.5 into, this is 1.5 by 2. Clear? This is at C is equal to, at C is equal to RA into 1.5 minus 1500 into 1.5 into 1.5 by 2. Now, what is RA? 7000. Put all the values, find at C. At C is equal, bending mode C is equal to 8813. 8813 Newton meter. At C. At A0, bending moment at A is equal to 0. Clear? This is a long question, 60 mark question. Any small minus sign, I forgot the minus sign, so I repeated this question, this answer 3 times. Clear? So understand clearly this problem. Very important question. Now draw the BM diagram. This is bending mode calculation. At B0, at E 1031 Newton meter, at D 12750 Newton meter, at C 8813 Newton meter, at A 0. Clear? Now draw the BM diagram. Take scale, 1 sum is equal to 1000 Newton meter. Take scale, 1 sum is equal to 1000 Newton meter. Now at B, just at B 0. At E 10313 E. Suppose this is 10313 Newton meter. A D 12750 Newton meter. 12750. 12750 at C 8813 Newton meter. Clear? It is 0. It is 0. All are parabolic because this UDL second power of second degree of x. So all diagram is parabolic. Right? This is 0, 8813 Newton meter, 1275 Newton meter, 10313 Newton meter, 0. Clear? This is parabolic. All are positive. So the diagram is about baseline. Again, the shear force changes sign at point D. At D, the beam is maximum is equal to 12750 Newton meter. Clear? At point D, the shear force changes its sign. The shear force changes its sign. Right? So at this point, at point D, the beam is maximum. The bending moment is maximum and is equal to 12750 Newton meter. Right? This is a very long question. A very simple question, but some small negligence makes our question difficult. Clear? So read careful and try to understand, solve the answer. Next question, 61. Question number 61. The question is, a simple subtractor beam may be A simply supported beam AB is loaded by udal of 3 kilonewton per meter over a length of 5 meter from the left support. From the left support. Draw the SABM diagram for the beam. For the beam. Clear? This is question number 65. The question is a beam may be simply supported A and B. This is RA. This is RB. Clear? The total length is 8 meter. Carries a udal of 3 kilonewton per meter for length of 5 meter from the left support A. Draw the SABM diagram for the beam. First find out the reactions at A and the reactions at B. That means R and RB. Let RA is equal to reaction at A, RB is equal to reaction at B. Clear? Now this is total load is 3 kilonewton for 5 meter. Clear? This is 3 into 5 is equal to 15 kilonewton. Right? Now upward force or downward force? What is upward force? Sigma y0. RA plus RB is equal to 15. 1. Take amount of day. Sigma y0. Clear? RB into 8 is equal to 15 into the 2.5. This is 2.5. Clear? So this is RB into 5 is equal to 8 is equal to 15 into or 3 into 5 into 5 by 2. So RB into 8 is equal to 25 into 3, 75 by 2, 37.5. Clear? What is RB is equal to? 37.5 by 8. 37.5 by 8. This is RB is equal to 4.68. RB is equal to 4.68 kilonewton. So what is RA? 10.32. So from equation 1, what is RA is equal to 15 minus RB, 15 minus 4.68, 10.52 kilonewton. This is RA. Clear? RA, RB. Now make shear force calculation. RA is equal to 10.32 kilonewton. RB is equal to 4.68. Clear? Now shear force calculation. Clear? This point C, this point A, C. Now shear force at B, just write 0. Shear force at B, just left, minus 4.68. Right? This is continue from B left to C. This point C. Now shear force at C. Shear force at C. C is equal to minus 4.68 kilonewton at C. At A, right, shear force at A, just right, minus 4.68 plus 5 into 3, 15, 10.32 kilonewton. A right, A left, shear force at A, just left, (10.32) minus 10.32, 0. Clear? Now draw the shear force diagram. First we will draw, this is shear force calculation. Now we will draw shear force diagram. A, C, B. Take scale 1:1, means 1 cm is equal to 1 kilonewton. Scale. Now shear force at A, B, just write 0, 0. just left minus 4.68. This is minus 4.68 kilonewton. At C minus 4.68. This is minus 4.68 kilonewton. At A just right 10.32. This is 10.32 kilonewton. At A left 0, 0. Right? Now join all the points. All the points. 0, 4.68, 4.68, 10.32, 0. This is negative, this is positive. This is negative, this is positive. This point is M. At M, this zero force changes sign from negative to positive or from positive to negative. So at this point, the bending moment is maximum. I will find out what is the value of M. Clear? What is the value of bending moment at point M we will find out. Let this is distance x, this is 3 minus x. 3 minus x. We will find out what is the value of x or 3 minus x. Bending mode calculation. Right? We first find out what is bending moment at point A, B, C and M. So where M lies? M is at distance x from A. Now find out x. The shear force changes its sign at M. At M, where the bending moment is maximum. The BM is maximum. Clear? First find out the value of x. Let the point M is a distance at a distance x from A. X from A. Clear? This point M is at a distance x from A. What is the value of x? So from figure, from this figure, this is a triangle, this triangle, both are similar triangle. So comparing this triangle A, this is suppose A dash M and C dash M. Now this way this is equal to this way this. Clear? From figure, for comparing two triangles, x by 10.32 is equal to 3 minus x by 4.98. Clear? So solving, find out x. Find out the value of x. Value of x may be, after solving, you get x is equal to 3.44 meter. This is 5 minus x. This is 5 minus x. Clear? This is 5 minus x. So after solving, you will get x is equal to 3.44 meter. Clear? Now find the bending moment at M, C, A and B. Clear? Now bending moment at B. First find out bending moment at B. This problem need calculator. Clear? I will not using calculator now. So use calculator to find the correct value. This is correct value. You can also find out the correct value. You can use calculator for solving the problem. Now BM calculation. At B, bending moment at B, 0. Clear? At C, BM at C, RB into, this is 3. This is 3. Clear? So RB into 3. What is RB? 4.68 into 3. RB into 3. 4.68 into 3. So this MC. This point M. Clear? So bending moment at C, MC is equal to RB into 3. What is RB? 4.68 into 3. This answer may be 14.04. 14.04 Newton meter. Kilo Newton meter. So MC is equal to 14.04. Right? At a 0. At 10. Bending moment at 10. Come from left. Left. This is 3 kilonewton per meter. This is x meter. Means 3.44 meter. What is this? This is 3.44 meter. So this is load 3 into 3.44 into this 3.44 2. Clear? So it is M is equal to, bending moment M is equal to R into 3.44 minus 3 into 3.44 into 3.44 by 2. What is R? 10.32. This is 10.32 into 3.44 minus this 3 by 2 into 3.44 square. Total square 2. Total square by 2. This M. This value may be 70.75 kilonewton meter. This is equal to 70.75 kilonewton meter. Now draw the diagram. A M C B, right? A M C B. Now at B0, at B0, at C, at C 14.04 at C kilometer meter. Suppose this is 14.04 at A0, A0 at M 7.75 kilometer. This M 7.75 kilonewton meter. Now join all the point. From A to C parabolic, from C to B straight line, inclined straight line. Clear? This is C to B straight line. This is parabolic. All are positive. So the diagram is above the baseline. This is SF diagram. This is BM diagram. Right? Now, this is question of 61. Tomorrow I will do some problems for this topic. Then I will start what is point of contrafracture. Only this topic. Point of contrafracture, point of inflection. Contrafracture, then I will start torsion. Bending stresses beam, thin cylinder, thick cylinder, stored column. Clear?